seventh technical experiment, the wind turbine geometries, is there to answer the research question, which is the optimal construction for a wind turbine to produce the most energy. So let's have a look. So for each experiment we do have a box full of plastic parts which we printed in a 3D printer, and as you can see here we can put them together in different shapes. So we have different length of blades. You can see here I used all of the short ones on this one, so we have 3 different lengths of blades. We can change the pitch as well when we put the blade into the central hub. So here we have a couple of options to change the pitch of the blade, and we can insert different numbers of blades, so starting from 1 up to 8 different blades. Now, if the wind is blowing outside, we can see how good this works. Well, it doesn't turn so fast, but it does turn. Then we can use a multimeter to see what is the outcome of the generator, of the electrical generator here. So we can go to these 2 cables, but don't touch, can hurt. And now we can see this is now 22 millivolts. Now we'll check the other one. But of course, you know, if you do an experiment, you should keep your controlled conditions. So the distance between the wind turbine and the wind generating fan should be always the same, because if you change that during your experiment, your results are not comparable. Now we can check this one. And we have 16 millivolts. So in this case, with this pitch and this number of blades, this one is not as good as the other one. So you can play around with your students to let them find out what is the perfect construction for a wind turbine. Another point you could test with your students is, if you put a couple of wind turbines in a row, then you see the wind turbine at the back is hardly moving. That's of course because it has a longer distance to the front part, but we could measure here now to see what the outcome is. And it is, oh, I switched it off. We can see what the outcome is on this side. Now in the moment we have 100 milliwatts, and if we take this now to the side that the wind can freely flow through, and we keep the distance, so we don't change the distance, we can measure again, and the outcome is already 210, so over double. So you can also discuss, if you have a green field somewhere and you want to put up these wind turbines, you can't just put them row by row, each next to each other. You need to keep some distance so that the wind really catches the blades and the wind turbine produces energy. From a cost perspective, this whole setup, as you can see it here in the moment, costs around 60–70 euros, which is about 1,400 South African rand. But the fan and the multimeter are the most expensive parts of these. So if you have a fan already, maybe in your office, or a multimeter in your workshop, you can save up to 50 euros, which means 1,000 South African rand. So the rest, the motor, the 3D printed parts, here we use just the plastic plate from the kitchen, some metal parts, that costs around 15 euros per experiment, which means around 300 South African rand. All these plastic parts you can see we used here, so the central hub, the blades, and this cap here in the front, which holds the blades in place. So if we remove this one and the wind turbine would turn too fast, then the blades might slip out of their place. So that is why we constructed this cap, and through the nozzles here it holds the plates in place so that they can't get out of the central hub. And all of these parts we constructed using a CAD program. The wind turbine was designed using a CAD, computer-aided design software, to design it in 3D. So we had a 3D model where we had to construct and design all the different parts. So the blades, the inner part and the cap. And as you can see here in the program, it really looks nice how all the 8 blades are flying around the middle part of the wind turbine. We can push them in again. And now you can see how it looks like if all the blades are inside the central hub. And the cup over the middle hub ensures that the blades can't get loose while spinning, while the whole wind turbine is spinning. And then we exported them to STL files and printed them on our 3D printers. So we'll provide these files on our website. Check out the description down below. There you'll find all the information. And as I said, this is already our 7th experiment. So if you're interested in all the other experiments we did, you'll find the playlist as well on our YouTube channel. So this experiment we use in the setup of renewable energies to teach our learners how these things work. In some countries, like in Germany, you see a lot of this wind turbines standing around everywhere. In South Africa, they will seldom seen, sometimes on the rooftop, somewhere a small scale one, but not these big ones with 100 meters of height and so on. If they see some pictures or some video clips, here they can test and play around and see, okay, what is the most efficient way to construct these wind turbines.